students, something that I find that confuses my students from year to year is this business of converting between, for example, milligrams to grams or centimeters to meters, and it really shouldn't be confusing. I think part of the problem is that every year a teacher has their own gimmick, and that gimmick works and the student learns it that way, and then the next year the teacher has a different gimmick, and that gimmick also works because it's math. There's multiple ways to do math. The issue is that in chemistry we use dimensional analysis all the time, and especially when we get to the chapter on moles and mole conversions. If you know how to use dimensional analysis in conversions, you'll know how to use dimensional analysis for moles, and it's something that you can apply to other classes. Any class that asks you to make any type of conversion, you're going to use dimensional analysis. So I'm hoping when I teach you how to do these metric conversions using dimensional analysis, that this is the last time or the last way you ever have to learn how to do it. Now, because dimensional analysis is very important, the process of it is very important. Even if you can do these conversions in your head, and some of you are able to, you still have to show the process. And you have to show the dimensional analysis process. I don't want you to use gimmicks that you've learned from years before, even though they work and even though they're fine. You can use those to check your work. But the importance of this lesson is understanding the process of dimensional analysis. So let's get started. The first thing we need to talk about is this table here. Now this table has, as you can tell, prefix, symbol, meaning, and exponent. And in life, if we do things and we act a little bit goofy, there's something about it that helps us remember it. So we're going to pull up our old inner elementary self, and we're going to just quote these. And I have some students who have good rhythm, and then they start beatboxing, and then it's really fun. But sorry, but I'm not going to beatbox for you. Now, I do want you to notice that I've got these listed going from large to small. So going this way, we're going from large to small. And then the base units that we're going through, are meters, liters, and grams. I know that the kilogram is a SI unit for mass, but the base units we use for our conversions are meters, liters, or grams. Meters is for length, liters is for volume, grams is for mass, as you know. Okay, so here we go. This is how we're going to say it. Giga, billion, 10 to the ninth. Mega,
million, 10 to the 6th, kilo, thousand, 10 to the 3rd, hecto, hundred, 10 to the 2nd, meter, liter, gram, base.
And now this next section is a mouthful, but it's important that we say it this way so that students don't write incorrect conversion factors. So here we go. Deci, tenth, but it takes 10 to make 1. Centi, hundredth, but it takes 100 to make 1.
Milli, thousand, but it takes 1,000 to make 1. Micro, millionth, but it takes 1,000,000 to make 1. Nano, billionth, but it takes 1,000,000,000 to make 1.
So now what we're going to do is we're going to take this table and we're going to use this set of guidelines to make these conversions. Okay, step 1 in the dimensional analysis grid says to set up a grid and to write down what you're given and what you want to find. Oops, I spelled "you're" wrong. Y-O-U apostrophe R-E, I apologize. And this first problem we're going to do is convert 6,230 milliliters to liters. Now, you can set it up one of two ways. I'm a messy person, so I set it up using a grid, but you can set it up using a series of fractions. They both mean the same thing though. So I'm going to convert 6,230 milliliters, that's my given, 6,230 milliliters, and I'm going to write down what I want to find. That's my given, that's step 1. Now, your teacher at your school, or you may have seen this done like this instead, it's the same thing, okay? This line here for me means divide, and these lines here mean multiply. It's the same thing. I use a grid because I'm messy, so I need to use the grid. All right, step 2 says, place your units correctly onto the grid so that you are left with what you want. Okay, So right here I have milliliters. I don't want milliliters. So in math, if I divide something by itself, I get 1. So if I have milliliters here, I'm going to place milliliters here. We're going to do this both ways. So I'm going to place milliliters here, milliliters here. Where am I headed? I'm headed to liters. Now look what's happening. Because of math says anything divided by itself is 1. So that divided by itself is 1, and I'm left with what I want. Same thing over here. This divided by itself is 1, and I'm left with what I want. So I've set up my grid. Boom, done this. I placed the units correctly on the grid. Now I need to make a conversion factor. Remember, a conversion factor is an equivalence. And an equivalence simply means that the two values are equal. Do you want 1,000 mils of water or do you want a liter of water? It's the same thing. I'll take either. Do you want a meter of gold chain or do you want 1,000 millimeters of gold chain? I'll definitely take either, whichever one you're giving away, because it's the same thing. Okay, so I'm going to look at this, and the first thing is I ask myself, which unit is larger? Assign a 1 to the larger one. So right now, I'm comparing milliliters to liters. So I'm comparing these two. Who's bigger, a liter or a milliliter? Well, you've been around long enough to know that a liter is bigger, so we're going to assign the 1 to liter. Then what does milli mean? Well, if we go back to our chart, right over here, it says milli means thousandth, but it takes 1,000 to make 1. So I'm going to put 1,000 down here. Not 1,000th. It takes 1,000 thousandths to make 1. Don't ever put a negative exponent. You could have put 1,000 or you could have put 10 to the 3. So if I'm doing this down here, I'm going to put 10 to the 3 just because I can. All right. So if you're doing this math ways, you're just got a fraction, 6,230 divided by 10 to the third, which is going to give you 6.230 liters. Boom, done. This line here means divide. 6,230 divided by 1,000 is 6.230. Boom, done. The next problem we're going to do is this one right here. It says convert 8.69 grams to milligrams. You're like, Mrs. Arrington, I've been doing this since the 5th grade. I can do it in my head. This is dumb. It's too many steps. Just bear with me. Learn to use dimensional analysis. We're going to use it all year long, and you'll be really glad you did. Okay, so I'm proud of you if you can do this in your head. Do it in your head quickly, and then let's use the process and see if we get the same answer. Okay, so this one says convert 8.69 grams to milligrams. So step 1 of my grid, step 1 says set up a grid and write down your given and what you want to find. Okay, so my given was 8.69 grams to milligrams. And if you prefer this way, the same thing. All right, place units correctly onto the grid so that you are left with what you want. Remember, you want the units that you don't want to cancel, and you want the units that you do want to stay behind. So in math, if we want to get rid of something, we can divide it by itself. So if I have grams here, what am I going to put down here? Well, yes, of course, I'm going to put grams down here. Because now, and then where am I headed? I'm headed to milligrams. Because now grams cancels with grams, and I'm left with what I want. Step 3 says make conversion factors. So I'm going to make my conversion factor. The first step of making a conversion factor, which unit is larger? Assign 1 to the larger one. Well, what's larger out of a gram and a milligram? Well, you know this from a prior year. Of course, a gram is bigger, so the gram gets the 1. And then M as the prefix, a baby m right here stands for milli again, and milli stands for 1,000th, but it takes 1,000 to make 1. So I'm going to put 1,000 here. Or if you're using this system, 1,000. So now what does that mean? Well, this one's very obvious. I just multiply And in my grid, those lines mean multiply, so I'm going to have 8.69 times 1,000, 8,690 milligrams. Now, if your teacher has taught you sig figs, you know that this is 3 sig figs. You can only have 3 sig figs in your final answer. There's no decimal point, so there is 3 sig figs. An even better way to write this would be like this. And then we're for sure about our sig figs. And then we're done. The third problem here says convert 3.2 gigaliters to liters. 3.2 gigaliters to liters. Okay, so step 1 of my grid says set up a grid and write down your given and what you want to find. Convert 3.2 gigaliters to liters. So I'm going to put down my given, put down where I'm going, and step 1 is done. Step 2 says place the units correctly onto the grid so that you are left with what you want. Okay, I have gigaliters here. What am I going to put down here? I'm going to put gigaliters. And I'm headed to where? Liters. Now, watch. This will cancel with this because in math, anything divided by itself is 1. I'm left with what I want. That's how I know I set my units up correctly. Now I need to make a conversion factor. I ask myself which unit is larger and I assign a 1 to the larger one. Okay, out of gigaliter and liter. Well, gigaliter might be a new prefix in your life, so let's go back over here. And here's giga, and here's liter. Gigaliter is a whole lot bigger. It's 1 billion times bigger than a liter. So it's the big one, and the big one gets the 1. But what does giga mean? Giga billion 10 to the 9th. Now, I'm not going to write 1 with 9 zeros here. I'm going to write 10 to the 9th because I have scientific notation. Students are like, no, you should have written it like this, Mrs. Arrington. You're wrong, you're wrong, you're wrong. Giga means 10 to the 9th. So I'm going to do that. Now, what is wrong with that? I just said that 1 billion billions make 1, and that is not true. It takes a lot of little things to make one big thing. Giga is the big thing. Giga means billion. It's 1 billion times larger than liter, so I need 1 billion liters to make 1 gigaliter. Now, this means multiply, and I don't even need a calculator. I can just keep this in scientific notation, and I am done. And my sig figs are correct. Why? Because I had 2 here, and I have 2 there. Boom. Done. All right, let's try another one. Okay, our next problem here, convert 4.3 times 10 to the negative 7th grams to nanograms. Okay, so my method says set up a grid and write down your given and what you want to find. So I'm going to write 4.3 times 10 to the negative 7th grams to nanograms. I'm going to show it both ways for those of you who prefer this second way. My math purists prefer this. But either way is dimensional analysis. It's just the preference on the grid or the fractions. Okay, then the next step says place the units correctly onto the grid so that you're left with what you want. And once again, I know if I have grams here, I'm going to want to put what there? I'm going to want to put grams there because grams will cancel with grams. Anything divided by itself is 1, and I'll be left with nanograms, which is what I want. So you check. Oh, that cancels with that. I'm left with what I want. That's how you know you set it up right. Then the next step is to make your conversion factor. And remember, a conversion factor is an equivalence. So you ask yourself, which unit is larger out of a gram or a nanogram? So we go back to our table. Here's grams, and here's nano. This is big to small, so nano is way smaller than a gram. So who's the big one? In this case, the big one is the gram. Okay, now we need to look at our prefix, nano, nano. Well, it says right here, nano means billionth, but it takes 1 billion to make 1. Okay, and this is where students fall in a trap. They're like, oh, she told me nano is billionth, and then they write 10 to the minus 9. Okay, nano means billionth, but it takes a billion billionths to make 1. So you're going to have to use a positive exponent because it takes a billion billionths to make 1. If that doesn't make sense to you, for now, just tell yourself never use negative exponents when we're writing conversion factors this way. But it's always better to understand why you do something, because if you understand why you do something, then you're less likely to forget it. Okay, now I'm going to multiply and hold the calculator because you don't need one to do this. Remember, when you are multiplying with exponents, you add them. So negative 7th plus 9 is going to be positive 2. So this is just going to be 4.3 times 10 to the 2 nanograms. Same thing here, 4.3 times 10 to the 2 nanograms. And I had 2 sig figs here and 2 sig figs there, and now we're done. Okay, I want you to write these last 2 problems down. I want you to try them on your own, stop the video, and then come back and I will put the answers up for you. Okay, hopefully you did these on your own, because watching somebody do math is about as useful as watching someone do gymnastics and then saying you know how to turn somersaults and do backflips yourself. You just don't. You have to do it yourself to know that you can do it. So let's talk through these last 2. In the first one, this was our given. This is where we were going. I had nanometers here, so I put nanometers here. I was headed to meters, so I put meters there. Then I had to write a conversion factor. Well, my big one out of meter and nanometer is meter, so meter got the 1. Nano means billionth, so instead of writing billionth, I knew that it takes a billion billionths to make 1, so I put 10 to the 9 down here. And then all I had to divide, 10 to the 8th divided by 10 to the 9th. I know when I divide with exponents, I subtract them, so 8 minus 9 was negative 1. And my answer was 7.56 times 10 to the negative 1. Now you may have used your calculator, which is fine, although sometimes our brains are smarter and it's better to understand what we're doing, and you would have gotten this. It's the same answer and it's the same correct number of significant figures, so you're just fine. Then the second problem was a whole lot easier. You probably were able to do this one in your head. In this one, you were given kilograms, so you put kilograms down here. You were headed to grams, so you put grams there. Your conversion factor, you know that a kilogram is bigger than a gram, so the kilogram got the 1. Kilo means 1,000, so it takes 1,000 grams to make 1 kilogram. So you may have, instead of this, written 3.75, and you may have put 1,000 up there because you don't like exponents. And then when you did it, you got 3,750 grams. It's still the right answer, and if there's no decimal point, it's still the right number of significant figures. So this answer here is 3.75 times 10 to the 3rd, or just 3,750 grams. Make sure you have your units in your final answer because you don't want any naked numbers. So now we're at the end of one-step dimensional analysis conversions, and the next video will be on two-step dimensional analysis conversions. But why don't you stop for now and don't learn the next set until this has settled in your minds for a day. Okay, have a great day. Goodbye.